Welcome to our Quantum Deep Dive.
Hello.
Today we're journeying into the complex world of J. Robert Oppenheimer. Now, when you hear his name, perhaps you picture the iconic father of the atomic bomb, right?
That's the common image, yeah.
But our mission today is to reveal a much broader scientific legacy. We want to explore his profound influence, especially on quantum technology.
That's right. And our exploration is deeply rooted in, a really insightful essay. It's called Robert Oppenheimer, Quantenphysiker und Wissenschaftsvisionär by Jörg Osch-Neppat.
Okay.
It gives us a crucial lens, to understand the entirety of his remarkable journey.
So think of this as your shortcut, really, to understanding this pivotal figure. We'll unpack Oppenheimer's incredible transformation from this brilliant theoretical physicist to the leader of one of history's most ambitious applied research projects.
Mm-hmm.
You'll grasp his enduring scientific contributions and the profound questions he raised that are still incredibly relevant today, especially, as quantum technology continues its rapid boom.
Absolutely. Let's dive in.
Okay, so where do we start? The context, I guess.
To truly understand the man, we first need to set the stage. The scientific whirlwind of the early 20th century. This was an era where classical physics, which had reigned supreme for centuries, was finally hitting its limit.
Absolutely. Imagine trying to explain everyday phenomena like how a piece of hot metal glows a certain color. That's black body radiation.
Right.
Or how light can literally knock electrons off a metal surface, the photoelectric effect. Classical physics it couldn't make sense of them.
Precisely. And out of that confusion, a new paradigm emerged. Quantum mechanics. You had giants like Max Planck, Albert Einstein, Niels Bohr, Werner Heisenberg, introducing these revolutionary ideas.
Totally new concepts.
Concepts like quantization, where energy exists in discrete packets, or wave functions, these mathematical descriptions of particles behaving like waves. These radical shifts, they completely redefined our understanding of matter and energy.
And it's into this revolutionary atmosphere that a young Oppenheimer makes his entrance.
Indeed. Born in New York City in 1904 to a wealthy, educated German-Jewish family, Oppenheimer displayed exceptional talent from a very young age.
You can see it early on.
Yeah. His family cultivated this deep appreciation for culture, which fostered his early brilliance, not just in the sciences, but also, in literature and philosophy. He was truly a polymath in the making.
That talent really exploded at Harvard. He started in 1922 and just flew through it, graduated in only 3 years with top honors, all while tackling this remarkably broad curriculum: chemistry, physics, literature, philosophy.
Quite the foundation.
What an intellectual foundation.
His insatiable ambition then pulled him to Europe, which at the time was the absolute epicenter of cutting-edge physics. He initially went to Cambridge's Cavendish Laboratory, but he struggled a bit with the experimental work there. There's even that story, maybe apocryphal, about him nearly poisoning a tutor.
Oh, wow.
It quickly became clear his true calling was theoretical physics, and that led him to the University of Göttingen in Germany, which was a leading hub for quantum mechanics.
And it was there that he had a truly monumental collaboration, right, with Max Born.
Exactly. Max Born, another titan in the field. Their collaboration in Göttingen culminated in 1927 with their seminal contribution, the Born-Oppenheimer approximation.
Okay, so what's the core idea there?
Well, the core idea is brilliantly simple, yet incredibly powerful. Imagine a molecule. You've got heavy atomic nuclei and much lighter, faster-moving electrons.
Right. Big difference in mass.
Huge difference. They realized that because of this vast mass difference, you could essentially treat the slow-moving nuclei as largely stationary while analyzing the incredibly fast-moving electrons.
So if I'm picturing this correctly, it's like trying to photograph a hummingbird. If you're also moving, it's just a blur. But if you stand still, you can get a clearer picture of the hummingbird. They found a way to stand still, quantumly speaking.
That's a fantastic analogy, yeah. This conceptual decoupling of movements made these incredibly complex molecular calculations suddenly manageable.
And this wasn't just some abstract theoretical nicety, was it? How did it actually, change the game for physics and chemistry?
Oh, it was revolutionary. Before this, predicting how molecules would behave was incredibly difficult, almost impossible for complex systems.
Right.
The Born-Oppenheimer approximation provided a conceptual lens that simplified this immensely. It basically opened up the entire field of quantum chemistry.
Wow.
It allowed scientists to design new materials, understand molecular interactions, predict molecular spectra with incredible precision, things that were previously just unimaginable. This was truly the start of his profound influence.
So the Born-Oppenheimer approximation laid a crucial cornerstone for molecular physics. But Oppenheimer's theoretical work, it branched out significantly from there, didn't it? Pushing into even deeper questions about the fundamental nature of reality.
He certainly did. Oppenheimer continued to make significant contributions across quantum mechanics and into the emerging field of quantum field theory, or QFT.
QFT, okay.
His research extensively explored electron systems and spectral analyses, applying quantum principles to complex molecular structures, all rooted in fundamental concepts like Schrödinger's wave equation, which, helps us understand the energy states of quantum systems.
And he didn't just stop at individual particles. He ventured into how fields and particles interact, which sounds like an even bigger conceptual leap.
It was. QFT combines quantum mechanics with special relativity. It allows us to describe how particles, like electrons and photons, interact and how fields themselves behave. He also deeply engaged with the Dirac equation,
Oh, yes.
a groundbreaking theory for describing particles like electrons, which led to predictions of things like antimatter and antiparticle creation. Really fundamental stuff.
It sounds like he was truly at the forefront of the theoretical revolution, often pushing the boundaries alongside other brilliant minds. He must have built quite an intellectual network.
He was indeed at the nexus of scientific thought. He maintained regular exchange with other leading physicists of his time, people like Paul Dirac and Werner Heisenberg.
Wow, the big names.
Yeah, they greatly influenced his understanding of relativistic systems and the fundamental principles of quantum mechanics. Beyond that, he also mentored many young scientists, helping to build this vibrant scientific community around him.
So what does this all mean for you listening now?
Well, his work, and the work of those he collaborated with, it laid the groundwork for entire fields like quantum electrodynamics and particle physics disciplines, essential for explaining the very fabric of matter and energy in our universe, and even how things like light interact with matter. It's fundamental.
This sounds like a purely abstract theoretical existence. But then, as we know, his career took this dramatic turn. The pivotal shift to applied science in the Manhattan Project.
That's right. The looming threat of World War II and the groundbreaking discovery of nuclear fission in 1938 by Otto Hahn and Fritz Strassmann.
And the theory behind it from Meitner and Frisch.
Exactly. Its theoretical explanation by Lise Meitner and Otto Frisch transformed nuclear physics. It went from an abstract curiosity into an urgent geopolitical concern practically overnight.
And Oppenheimer was the man for the job.
Well, his unique blend of deep theoretical insight and a practical understanding of how to implement physics, it made him seem like an ideal choice to lead the highly secret Manhattan Project.
Leading Los Alamos must have been an immense undertaking. A place of truly immense scientific and technical challenges, all under incredible pressure.
The challenges were indeed immense. A key task, for example, was calculating the critical mass of uranium-235 and plutonium-239 needed for a self-sustaining chain reaction.
The core of the bomb.
The core of the bomb. And quantum mechanics was absolutely foundational for these calculations, particularly in neutron scattering theory, which describes how neutrons interact with atomic nuclei.
So quantum mechanics wasn't just theoretical window dressing here. It was the actual blueprint for designing a device with unprecedented power.
Precisely. Quantum mechanics, through these counterintuitive concepts like quantum tunneling, where a particle can, in essence, magically pass through a barrier it shouldn't be able to cross classically.
Wild stuff.
It explained how neutrons could effectively breach the nucleus and start that chain reaction, releasing vast amounts of energy. And what's truly remarkable, kind of an interesting side note, the theoretical models developed at Los Alamos, though focused entirely on creating bombs, also unexpectedly laid crucial groundwork for later nuclear fusion research, even though fusion wasn't directly relevant to the project's initial goals.
Wow. But with such incredible power comes an equally profound moral dilemma, right?
Yeah.
One that Oppenheimer himself famously grappled with.
Oh, absolutely. His critical self-reflection began almost immediately after the Trinity test on July 16, 1945. While it was undeniably a scientific triumph, the sheer destructive power weighed heavily on him.
That's when he said the famous line.
Yes. He famously borrowed a line from the Bhagavad Gita stating, "I am become death, the destroyer of worlds." This quote perfectly encapsulates his internal conflict. A profound pride in scientific progress mixed with this deep concern for the humanitarian consequences.
And that profound conflict didn't just end with the war, did it? He truly believed in the international control of this new power.
No, it definitely continued.
Wow.
Post-war, he became a vocal advocate for international control and disarmament of nuclear weapons.
Which didn't go over well everywhere.
No. This stance brought him into direct conflict with political leaders who wanted to maintain American nuclear superiority. And this ultimately led to his security clearance being revoked during the McCarthy era in 1954.
A really difficult time.
Yeah, a clear instance of political pressure impacting a scientific career. His struggles highlight the enduring question, of a scientist's responsibility for their creations and how that responsibility plays out on the global stage.
After the war, though, despite the political fallout, Oppenheimer shifted his focus back to more peaceful scientific pursuits.
He did. From 1947 to 1952, he served as chairman of the General Advisory Committee of the U.S. Atomic Energy Commission, the AEC. In this role, he actively promoted international arms control and championed the civilian applications of nuclear energy, envisioning its use in areas like power generation and medicine.
And beyond policy, he also took on a highly significant role in fostering fundamental theoretical physics, didn't he?
Absolutely. In 1947, he became the director of the Institute for Advanced Study in Princeton.
Ah, yes.
Under his leadership, it became this global hub for theoretical physics. He collaborated with brilliant minds there like John von Neumann and Albert Einstein, really pushing the boundaries of fundamental research.
But then came the difficult McCarthy era, which, as you mentioned, cast a long shadow over his career, culminating in that 1954 security hearing.
It was a brutal period, the 1954 security hearing. It was fueled by his past political connections, his associations, and his cautious stance on the hydrogen bomb.
Right, the H-bomb.
And it resulted in his security clearance being stripped away. It was a personal humiliation, no doubt, and a severe blow to his role in science policy. However, it's important to note, his scientific reputation among his peers remained completely intact.
That's interesting.
And what's truly fascinating, maybe even ironic,
Go on.
this setback, forcing him out of government-related work, arguably pushed him deeper into fundamental research. It sort of allowed him to focus intensely on establishing quantum physics as an independent and internationally recognized discipline, away from the political fray, in a sense.
Which brings us directly to today. Why should you, our listener, care about Oppenheimer's work now in this age of quantum computing and advanced quantum technology? How does his legacy directly impact what's happening now?
Well, his work is foundational. I mean, truly foundational to the very core of modern quantum technology. Take quantum computers, for instance.
Sure.
His contributions to the principles of superposition, where a quantum particle can exist in multiple states at once, and entanglement, this weird linkage between particles.
Spooky action at a distance.
That's the one. Along with his work in quantum field theory, they form the bedrock for quantum algorithms and how we actually try to build these machines. His early ideas on using quantum mechanical superposition states for calculations are directly relevant to how quantum bits or qubits function today.
So his theoretical deep dives back then are quite literally powering the quantum machines we're striving to build today. That's kind of mind-boggling.
It truly is. And the same goes for quantum cryptography. Concepts he helped theorize, like Heisenberg's uncertainty principle, the idea that you can't simultaneously know both the position and momentum of a particle.
Can't pin it down perfectly.
Right. That and entanglement are absolutely fundamental to secure communication methods like quantum key distribution or QKD. These are real-world applications right now of the very quantum mechanics he helped define decades ago.
And in the realm of creating entirely new materials, what's his impact there?
The Born-Oppenheimer approximation, which we talked about earlier, it continues to be an essential tool for materials science and quantum chemistry.
Still relevant.
Absolutely. It allows scientists to precisely model complex molecular structures, leading directly to the development of new materials with specific properties and the creation of novel chemical compounds. So in many ways, his theoretical foundations are actively shaping today's most advanced technologies. You can draw a direct line.
What an incredible, truly complex legacy. Oppenheimer was such a pivotal figure, moving from these profound theoretical insights, like the Born-Oppenheimer approximation and his pioneering work in quantum field theory, to leading one of history's most ambitious and frankly impactful applied science projects.
Yeah, his work is marked by a deep ambivalence. He was a scientific visionary who also facilitated unimaginable destruction, and he grappled intensely with his moral responsibility. That famous quote, "I am become death, the destroyer of worlds," it just powerfully captures this duality, doesn't it? Scientific triumph and profound ethical burden all wrapped up together.
So what can we, as curious learners today, truly take away from Oppenheimer's life? What's the final provocative thought for you to mull over after this deep dive?
Well, several things come to mind.
Firstly, there's the undeniable importance of scientific curiosity and interdisciplinary thinking. Oppenheimer's ability to integrate knowledge across vastly different fields, from theoretical physics to literature, proved crucial. That same kind of broad, connected thinking is absolutely vital for modern quantum research. You can't just stay in your silo.
That's a great point. And secondly, his struggles serve as this enduring reminder of the responsibility of science. Technological progress, it has to be pursued with a profound awareness of its social and political implications and how it can impact humanity.
We have to think about the consequences.
Exactly. The story of Oppenheimer urges us to constantly consider the broader consequences of our discoveries.
And finally, his post-war advocacy for promoting international cooperation seems more relevant than ever, wouldn't you say?
Absolutely. He recognized early on that science transcends national borders. And that insight is crucial in our globally connected world, especially as we face shared challenges, like those presented by emerging quantum technologies and their global impact. Science is a global endeavor.
It really is.
We encourage you to continue your own exploration of these fascinating topics, delving deeper into the history and implications of quantum science and the incredible minds behind it.
We really hope this deep dive into the legacy of J. Robert Oppenheimer, based on the insightful work of Jurgo Schneppat, has sparked some new curiosities for you. You can find more information about Jurgo Schneppat's work at schneppat.de.
Check it out.
Until next time.